Let's set up the. Well, first off, thanks y'all for having me. Really excited to be here. My first time in St. Louis. Really excited to see, meet Bob and kind of see what engineering we're launching here. Because it's not every day that we get to launch a new engineering office and get to see the challenges and all the people that we get to meet. So today I'll be talking about, let's see, record, display, that one. There we go. So talking about shared infrastructure. It's an often forgotten about portion of the engineering work we all have to do until you need it and it breaks and then everything goes horribly wrong. So when you're a small company, just about everything is really easy, right? If you've got a single Rails application, Rails does most everything for you, and everything else you can kind of manually configure, and there's not really anything that's super difficult. Configuration, everything's in one place, right? Like if you need to find a value, you just grep in the repo, pretty simple. It's not really difficult to keep anything in sync because everything's in one place. Data access, right? You've got one database, direct access to the models, no difficulties there, right? Like easiest thing you can do. And session management, right? Rails provides that for you by default. You run BE rake secret, you get the secret you're going to use, and you're ready to go. Instrumentation is the only thing that can kind of get a little tricky because you either need to build up some infrastructure or pay someone else to do it. It's often easier for smaller companies and more cost-effective in terms of otherwise dedicating that engineering work to pay somebody like Datadog or New Relic or Skylight or one of the many other application monitoring solutions that are available for you. As you grow, you probably want to start extracting certain pieces of that main application out. Maybe it just doesn't, new pieces don't make sense in that application. And as you do that, everything gets more difficult. Configuration, oftentimes you'll end up copying things between repos and manually ensuring everything's consistent and coordinated and that the deploys went out at the same time, that everything kind of works. And if you're looking for a specific configuration parameter, you've got to make sure you look in every repo and maybe it's in a different place than you expect. Data access. You need to introduce some way for your applications to talk to each other. Traditionally, this might have been a hardware load balancer, though in today's containerized world, you'll see often things like Envoy or LSTIO and stuff like that that'll make that service mesh a little bit easier. But even once you have a transport layer, you need a way to decide on a serialization format. JSON, again, is a popular choice here because Rails makes it really simple to do. And in Ruby, working with hashes and JSON is a method difference. Really simple to work with. And then even after that, you need to have applications authenticate each other, right? Like, who is this application? Are they calling internally? Make sure they're allowed to access that data. Data controls, especially at a company like Square, are extremely important to make sure that people get the right data when they can and nobody else can. Session management. This one has probably the most variability in terms of difficulty. Oftentimes, when you're still starting off pretty small, you'll continue to route all the applications through your main application, or all the requests through your main application, and then you'll just proxy them through to another application. But that kind of main application is still your session management platform. But if you want to start moving requests directly to those applications, you're going to need more code. If you have all Rails, you can kind of make it work. But let's say you throw Go or Java in the mix or any other one of those languages. Well, they don't have the exact same session library, and now you're going to hit some difficulties. And instrumentation. A lot of teams will continue to remain with something off the shelf, though maybe you only run it on certain applications or a certain subset of application hosts that are running those applications due to cost. Often companies here start to look towards things like Nagios or Graphite or Prometheus or one of the many different application monitoring solutions you can run in-house. But again, you got to remember that's engineering work there that you could maybe dedicate elsewhere. So once you get really, really far, really nothing is easy, nothing's tricky, just everything is really just a pain. Configuration, this is often where you want the platform to tell you things. It's no longer, hey, the application configures its own database. The platform tells you where your database is. You really don't care where it is as long as everything's configured correctly. You want the platform really to tell you things like that. Otherwise, you got to manually manage that configuration, and often you need someone to coordinate those things, right? If somebody's like, here, you need to update your username here, then they need to make sure that was updated and that you deployed, and that they can revoke the old credentials and stuff like that. And that's often engineering time better spent on the product. The reason you've started your business, dedicate that time there. Service-to-service communication, right? You might hit scaling issues with things like hardware load balancers and either have to shell out a lot of money, they're very expensive, or optimize resource usage, maybe do certain things that you reduce the load there. And with a service mesh like Envoy or one of those other ones, it's easier, but it's not easy, right? You might need a more complex control plane. You might have, need to configure things on multiple coasts of data, like data centers on different coasts or availability zones in the cloud. You might have a Japan thing that can only run in Japan, and a thing that can only run in the US, and a thing that can only run in Europe, right? Like Germany has some really strict data protection laws that you often need to run in Germany. Well, then you need to route a request there. Like you need a lot more of that logic that you didn't previously need. And instrumentation, oftentimes companies will just rely on their own in-house solutions. There's pluses and minuses of that, but often, if you're a company like Facebook, at that scale, they don't pay to outsource that because it's significantly cheaper for them to optimize those resources in-house. I once attended a talk about how Facebook did some of their metric storage stuff. And they had PhDs working on it because that made numerical sense when it came to the amount of server dollars they could save and energy they could save. Like, you hit interesting scale, economies of scale there. So story time. So for a quick refresher, or for people who aren't super familiar with the in-depth details around how Rails does session management, you're about to get a crash course. So by default, everything is encoded into a cookie using that secret that you normally generate with BE rake secret or Rails secret, depending on your Rails version. There are a handful of issues with this approach. First, you've got a single secret that encodes every single one of your sessions, which means if that gets leaked, it's not going to be a fun afternoon for you. So you need to keep it extremely safe. And the problem is when you've got a lot of applications, a lot of engineers, how do you keep that very, very secret value safe? In addition, there's no easy way to rotate that secret without forcing everyone to log in again, right? Like if you deploy a new configuration, like you change the secret, Rails is going to be like, well, this session's invalid, force you to log in. You may not want that for a number of reasons. It's definitely not the best customer experience. People forget their passwords all the time. We see that in our customer success. They don't know what email they even signed up for the account sometimes. And also, a really critical security thing is that by default, the server has no way to invalidate the session. You can, even after you log out, if you still have that original cookie value, you could still send requests with that cookie value, and it's going to continue to work. You can change that in Rails, but it doesn't work out of the box like that. And a critical thing that Rails uses the session for is, security-wise, is CSRF protection. If you're not familiar, CSRF stands for Cross-Site Request Forgery, and protects against malicious requests from other websites using existing sessions. So like, you can put an iframe on somebody else's web. If you don't have protection against this, a victim could click on something like any arbitrary website, and it could send a post request to say squareup.com/deposit my money to this bank account. And that would be a really bad thing to have happen to your account. And it is arguably one of the most critical pieces of security in your Rails application. So in the early days of Square, we had one application that we simply named Web. And we used Rails built-in session management, and everything was great and simple, and that's not the way it stayed. So as we started growing, we started adding more Rails applications. We also introduced some Java applications. At first, we ran everything, as I mentioned before, you can just run everything through your main application, and that works great. But as you move more towards a service-oriented architecture, applications other than web needed to start decoding those sessions. So with other Rails applications, you could just configure the same as the main application. You say it's the same cookie name, same secret, ta-da. However, if you have Java or Go or any other language, they don't have that exact thing, right? So either you have to duplicate that logic or figure something else out. And in older versions of Rails, previous to 4.2, it was relatively simple logic. Random bytes, base64 encode, relatively easy to copy. However, Rails 4.2 increased the security on CSRF tokens due to an attack, compression attack on SSL that you can read all about if you want interesting paper, but they in turn increased a bunch of logic there. And even then, copying around logic between different applications, different languages, is just never going to scale. It doesn't really work that well. So we figured out a solution, and the way we went was we went to a central session management application named Multipass. So first off, it solves some of the issues with just a pure cookie storage management solution, including backing the sessions in a database. So that means if you click log out, the session gets kicked out of the database, and that means that session cookie can't be reused, and we'll notice it's invalid. Though in Rails, you can do that with some extra configuration if you want to store it in your database. And a common issue where you have multiple services handling a request is validation and trust. You might have each service validate, in the chain, validate the session. Obviously, you need some other way to pass it along, unless you can just pass along the cookies header, but like it's kind of hacky, and it's not, internally those requests aren't actual web server, like those are S-to-S requests between services, not a browser talking to an application. But that duplicates a bunch of work, right? If you have 5 services that all need to validate that session, you just increase your response time linearly with how long it takes to validate the session. Another option is you can only have the first service validate and just kind of implicitly assume that it's going to be fine along the way. But internally, you could craft requests, right? Which is not a great idea, and it's pretty tricky and a non-starter at companies where you're dealing with people's money. People get very sensitive when you deal with their money, good reason, but in general, you end up having to be a little more careful around some of the choices you make. And again, if you just did that, and let's say you opened up a new endpoint on that application to the internet, and you forgot to add that check, now you have an endpoint that isn't session management checked, and you now just are leaking a bunch of data. So the way we solve this is by having the first service decode the cookie, and then call multipass to validate the session. Multipass then returns a cryptographically signed blob of data. If you're familiar with JSON Web Tokens, it's very similar in that approach. But basically, every application at Square has access to a public key, and so it gets a response from multipass, and it checks to make sure that it passes that. So even if somehow multipass returned a bad result, or was trying to fake out that, or you tried a million other ways, it still has to be cryptographically signed, which means you have to have root access, like keys to those keys, and there's only a handful of engineers who have access to that, so that the attack surface is limited. And then on subsequent calls to downstream services, we pass that signed blob of data in a header, and then those applications can repeat the public key verification. And originally, we chose to replicate the way Rails encodes sessions due to how we originally integrated it back into Rails. So our first pass at integrating this had 2 pieces. First off, we had a piece of middleware that was configured with the cookie secret, and it was responsible for decoding that shared session, and then it placed it into the rack environment. Note that we really couldn't configure the default session store on those Rails applications to be that shared session, because let's say you have an admin panel and you try to do session flash, and then you have another admin panel on another application. Well, those values are going to get copied if you're sharing it all over the place, and you're going to get some really weird user behavior. And that's just internal. You might cause some other issues that'll actually hit customers. And then in the controller, assuming this was the first service in the chain, it would then make a call to multipass and validate the session. And then in order for Rails to get the CSRF token from the shared session, we employed a number of techniques over the years, monkey patching, copying into the main session, so just being like, oh, take it from here and put it in here, and Rails will find it, and ta-da, everything's happy. But all really had significant drawbacks. None really worked as well as we wanted it to. And then, as I mentioned, with Rails 4.2, we had to monkey patch even more because they changed that format. And that makes it difficult when you have multiple Rails applications or even rolling out a single version. So things like CSRF are incredibly difficult to change in a safe manner so that you don't fail good requests and you continue to fail bad requests. Even if you have just one application, if you're deploying a Rails 4.2 upgrade, like you just decide, hey, we're going to go to Rails 4.2 today, and you start deploying, there's a period where some sessions, your first request hits the Rails 2.4 host, it'll get a masked token because they started masking them as part of that security fix. But the problem is, let's say the next request hits a host that hasn't gotten that new code. You'll get a 4.2.9 because it can't validate that. It goes, this is some gibberish, you're trying to do something funky, we're not going to allow it. So you have that issue. Rails has gotten better about opting into features after you deploy, so you can say, hey, we're gonna deploy the Rails 5 upgrade, and then we'll enable this feature. And so some of that's simplified, but even then, in this case, you would have actually failed requests. And depending on how many hosts you have, like at Web, I think at that time we were running 30 or 40 in each of our data centers. I can guarantee you some requests failed, and people were like, what happened? Most of the time you can refresh, it's fine, but like that's not the customer experience you're looking for. And then even if you expand upon that to multiple applications running different Rails versions, you can see it's really complicated to try and manage this exact logic being copied and monkey patched into every application, and that doesn't even include any other languages you have to support. So our next iteration moved a bunch of this logic back into multipass, and then handles the rest in middleware. So now multipass, we just send the whole cookie. The application, each application, frontline application, no longer has access to that global cookie secret. So multipass is now responsible for decrypting it and validating it. The only duplicated logic is in verifying the response, which is the public key encryption. And that response also includes the CSRF token you want to use. And then all you need to do is to validate that the one you're getting sent is the correct one is just simple string equality. Obviously, you want to make sure, remember to use a constant time string equality function so you prevent yourself from timing attacks. But other than that, you don't have to deal with any base64 encoding. URL is safe. So like we've had that issue before where one application was URL safe encoding it, another application was trying to strict decode it. It would blow up because it's like, this isn't valid base64. You hit stuff like that that are really tricky to track down, and those reports aren't really obvious to you, right? Like there's no like alerting you can check that's obvious that like, oh, hey, we're failing every request, because you might only fail a handful of them because only a handful of those characters got encoded the way that would break that encoding. So we have an existing public gem called Rails Auth. You can check it out on GitHub, but it's a generic auth-z, auth-n framework. So we can define ACLs and who's allowed to do what. And then we tapped into that, and along the request, it carries a set of credentials. It says like, hey, this request, so we have an internal system for our single sign-on. So it's like, hey, this request came from this actual user. So my LDAP's Alex C. It's like, oh, hey, this came from Alex C. And you can say, this person, that, like, I belong to these certain groups. This, like, one of those groups is allowed to do this action. If you're not on that list, you get denied. And so that's passed along in the rack environment. So in the controller, when it goes, hey, is there a multipass credential available? It would only be present if it was valid, and then if it was a web request or like had needed CSRF protection checks, if it had passed those. You might think like, hey, this is a perfect solution, everything's easy, thanks for solving this for me, take this home, copy it. Not so fast. So software engineers were constantly tweaking and redesigning things, and these are a few of the things that have popped up since we pushed that code out, and more people started to use it. So one of the major issues with the middleware approach is the way we took, and just using middleware in general, is how request logging in Rails works. It relies on active support notifications issued by controllers, which means that any requests that don't reach Rails controllers are just completely missed in your logs. So that includes other things like other rack applications that might be mounted in your routes file. If you use Sidekick as a job processor, that web UI is a really good example. You won't see any of those requests in your logs. And middleware that handle the entire request will just be completely omitted. So that's not great if your middleware is the one doing the CSRF checking and your middleware is the one sending back that 429 that says like, hey, this is wrong. Also, if you have any middleware that change the response code or they handle an exception, maybe they see an exception, Rails thinks it should return to 500, but that middleware goes, oh no, this one is a 301 or whatever, that won't get reflected in your logs. So as a result, as I mentioned, whenever our middleware detects that CSRF mismatch, that 429 it returns to the client isn't logged. And that's really critical because let's say you're rolling out this code, you want to make sure everything's going fine. Well, if your logs don't include this stuff, that's not easy. Mind you, you can look at your web server logs, like you can look at Nginx or whatever else you might use, and you can decode it from there, but that's probably not the logs you're looking at. You're looking at your Rails logs because those are normally the most informative of like, hey, this is how much time I spent in the view or my database or any other metadata that like the Ruby app would know, but that really Nginx won't know other than like response time, response bytes, response code, stuff like that. Note that this isn't a unique problem to us. It's just not commonly noticed. We hit it, and we run a bunch of Rails applications, and a bunch of other Ruby engineers were like, oh, hey, that's surprising. And people hit it even less because you don't always look at your logs unless you're looking for something specific. And you might not notice something missing. You'll be like, oh, everything's fine, but if it's missing, is everything fine? So you're kind of lost there. There's also ways people use your code that you never expect. Surprise, surprise. A need that quickly popped up was support post requests for public endpoints. So like think of a lead form. They're like, hey, I want to contact Square Sales. and like I want to talk to somebody on our sales team. You don't really need to log in for that. But you might have a session that's valid, but we don't really care about that. So as a result, we added the ability to configure paths where the session decoding and validation is just completely bypassed, and we just move along. A thing that would have made this a little bit easier would have been anonymous sessions. That would have been actually a nice thing if our session management system had that, but we don't. You might also end up in a state where there are multiple realms of users that might want to log in. For example, let's say you're a food delivery service. You might have a login for your restaurants that are like, they can send out the orders. And you might have a login for the people delivering the food who need to accept those orders. Most likely, those will be two completely login realms, right? Like you might have a table for one and a table for another where they don't overlap. Maybe you want to have people who can be restaurants and couriers. I don't really know, but stuff like that, you've got to make sure you're going to probably eventually run into. We hit it all the time. We launch a new product and we're like, oh wait, this user base originally was just Square merchants. A good example is Square Capital. Originally it was just for, which is where we give out loans to small businesses, and originally it was just Square merchants. So easy, everything, you just go through your regular Square dashboard, problem solved. But the problem is, let's say we start issue them to not Square sellers, which we do now. They need somewhere to log in, but they don't really have a Square account. So you have to start thinking about different ways that you might need login mechanisms where the realms are a little bit different. And you might also have different session types. You might have one for the web, where maybe you want to be logged out after 30 minutes. And you might have another one for your mobile device application, where you have to log in every 45 days or something like that. And you want to be able to enforce different session stuff there. You gotta make sure you remember that kind of stuff. So I've got up here a couple other patterns I've either done myself or seen used. For data access, it's not uncommon for multiple apps to share the same database. We still have, I think, at least one or two that we're still, regulator still is still working on that. Technically, it's only for test, but in production, it's not there anymore. But like stuff like that, and that's been something we've been trying to kill for years. It's often at the beginning easier to figure out. Like it's often easier than trying to figure out a way for these applications to communicate. Especially 5 or 6 years ago, where you didn't have containers and you didn't have the cloud, and a lot of this cool orchestration stuff wasn't available, and you had to just build it yourself. But long term, I can promise you, it's painful. It takes a very long time to undo because you forget about, oh, maybe this application made a change to one of the tables, and I don't see that change, and then Rails blows up. You're not gonna have a good time. Like session management, API formatting is another choice that's often made early and copied around. It's a little bit easier since not everyone has to agree, right? Like you could have some services that talk one, some services talk another. Not quite like session management. JSON, again, I mentioned earlier, often selected due to simplicity, but long term, it's not an optimal choice. First off, if you've ever worked in a typed language, like Go or Java, which are the other two primary languages at Square for server work, it's significantly more difficult to work with an arbitrary map than typed objects. You're going to spend a lot of time writing converter code, like, oh, this is a string, or I need to make sure I cast this, and if there's a cast exception, then I need to catch that and throw an error, and like stuff like that, you have to write a bunch of logic around. And also, you don't notice those changes at compile time. You notice them at runtime, and maybe not right when you deploy, maybe a week later, maybe a month later. We've had this happen at Square. Someone's like, oh, where did that field go? And it's like, oh, I removed it. And you're like, oh, thanks. And the behavior wasn't critical because it's like, oh, if this field's there, do this, but that might have impacted something else that it didn't expect. So we primarily use what are called protocol buffers. They're open source by Google a few years back. But essentially like a way to define an object or an RPC service, it also supports that is typed. So you can say like, hey, I want this field to be a string, I want this to be this, and then it'll generate the code for Ruby, for Java, for Go, a number of other languages. You have typed support where you need it, and so in those typed languages, everything's easy. And also you notice, especially in typed languages, you'll notice, let's say somebody removes a field. You update your version, and it's like, oh, well, I was calling this method and it's gone. Let's look into that. Why did that happen? You get a much quicker feedback loop. And I can promise you, we use these. They're amazing. I think they're probably one of the things I evangelize the most because they make my life and every other engineer's life just significantly easier. You never really have to worry about coordinating changes. Like I was like, oh, I want to change this thing over here. Took me like an hour to change it in mine, change it in another service, and change it in a third service. And it's all typed, and I was like, cool, compiles, we know we're good. When it comes to instrumentation, early on it's easy just to skip it, right? You're like, oh, I'll get to it later, or like when we deploy, we'll just check some logs, and like if I don't see any massive amount of errors, I think we'll be fine. But solutions like Datadog and New Relic make this really easy. Like they can be a little expensive, but even if you just run it on one host or like just a little bit, it'll give you a good sample of what's going on, and maybe, oh, hey, there's this thing. Like a while back, we had our internal user management system was doing this query in MySQL that was taking like 25 seconds to generate basically a cross product between a bunch of rows and a bunch of rows. Not very efficient. Looked at it and we're like, oh, cool, let's just do that in Ruby. Response time went down to like 150 milliseconds. Much better. But it highlights stuff like that. You're like, oh, what are the low-hanging fruit? Like, there's obviously not a lot of stuff. I recently noticed it's been noticing like a slight latency spike every once in a while. And so now we're looking into that. But like, it makes your life a lot easier when you don't have to do that. And you don't often discover the metrics you want to know until you need to know them right now. You're an outage, you're like, oh, what is this doing? And you're like, I don't know, and it's going to take an hour for me to be able to deploy a change that includes enough instrumentation that maybe I'll figure out what's going on, but I don't want to deploy because my service is already kind of wobbly, and if I do that, then we're just going to go down and stuff like that. So Datadog and New Relic, a lot of those things instrument a bunch of things automatically for you, and at least give you a slight breadcrumb trail that you can kind of maybe find out what's wrong. Not always, but it helps you get there. And I commonly see configuration and similar like library code copied around between applications. A lot of the times I look at an application, I'm like, that thing's been dead 4 years. And I know you never used it because nothing ever used it that was created that recent. I was like, it's obviously that it was just copied and pasted from another application. And it makes cleanup trickier because then you have to look through the whole repo. Is this used? Is maybe use one of my libraries and somehow I wouldn't notice if it's used? If you need some code in more than one application in Ruby, turn it into a gem. It's really easy. You don't need a private gem server. You can just use a Git repo and tell Bundler like, hey, look at this this Git repo, and ta-da, you're done. Makes your life a whole lot easier. It has versioning. You know, you're going to get the same exact library code every single time. Life's pretty easy. So now let's look at how we've solved some of these challenges at Square. So we have what we collectively call the service container. We have one of these in Java and Go. They're a little bit more involved. In Ruby, we have a collection of gems that we collectively define as the service container. Some of them are used by all applications, some of them are not. A little lighter weight. But basically, everything you need to integrate with other applications at Square, we provide. For example, SQAuth is built on top of RailsAuth, and it's the authz, authn, to make sure that like whoever is talking to you is allowed to talk to you and do whatever that action might do. An SQ connector is what we use to make calls to other services. You might think that's really easy, but depending on what you do and how you set up connectivity, copying around, you'll end up being like, oh, well, I just need to copy this one little line across all these applications. Then it'll be 2, and then it'll be 3. And then, oh, what do you need to make a change across all that because you're changing something in your platform? Now you go and make 30 changes. So this makes that easy. You're just like, hey, I want you to talk to this URL. Here's your base timeout. It builds up a whole client for you, and then you just immediately talk to it, and it's easy. And then a handful of other gems here. This is just a handful. We've got, I think, 10 or 11 core gems, and then probably another 20 that are integrated on a more outer ring. And then each of them are designed to work independently. Their public APIs might be a little bit verbose, not quite perfectly sensible, for a reason I'll talk about in a second. But each independently can work. So that means, let's say you just want to use that one library, or a good example is you just, like you're not even deploying a Rails application, you're just deploying this random thing that just needs to be able to talk to other services. Well, if you integrate it too deeply into Rails, you're not going to have a good time. So a lot of all these things are mostly independent of Rails. Some are a little more, some are a little less, just depending on what they're doing. Like SQAuth, even though RailsAuth is named RailsAuth, it's actually more RackAuth because it doesn't really use any Rack-specific or Rails-specific features other than some stuff in the controller. But you can easily not do that. So SQAuth you might use even if you're using Sinatra or any other web application server. An SQ connector, you might just need to use one-off. We've seen cases like that. Our platform security team is like, I need to run this script on every box. And if it was too integrated with Rails, then it doesn't really work that well. So this all leads me to what we call SQ Common. It's responsible for providing all the glue between our platform gems that we write and all the open source gems that we use, and just make everything kind of easy to work with. So outside of the Square platform gems that we have, it's responsible for configuring, we use Datadog, Kafka, MySQL, Puma, Redis, secure headers, Sidekick, Zookeeper, I think a handful of others. But those are just the core ones you need to have if you want to integrate with application, even just integrate with the Square platform and the things that are provided to you by other engineering teams at Square. And most of them require absolutely zero configuration. If you just add SQ Common, you automatically get a automatically generated database.yaml. It's done for you. Literally, you have to do no work, and now you're automatically connected to the database. Same with Redis, automatically done. If you have a Redis cluster configured by our data source team, automatically you can just access it. You just do sq : or common.redis, and you now have an access to that connection. So we make everything easy when you don't need to really change a lot of this stuff. And all configuration is handled via YAML files, so they get merged together. So you can have, there's a global config file, a environment config file, and then a data center / environment config file. So you can be, hey, I want to name this globally, or I just want to run this one job in this one data center, or stuff like that, and that gives you the flexibility to do so. So here's an example of what the basic configuration of an app today looks like. So you notice I mentioned you automatically get your database, you automatically get Redis, so they're not really mentioned here. But you know, auth, we want to enable our auth-z, auth-n framework, our exception notifier. So hey, this is the service you should talk to. If you want to use Sidekick, you want to have SQ Common configure your Sidekick Redis for you, you can say, hey, just enable that and true. Or I want distributed tracing, just turn that on and ta-da, you're done. So for development and release, we don't have any dedicated engineers working on these gems. We recently had a team spin up called Frameworks who work on some of the general shared infrastructure at Square, whether or not that's language specific or some general things that are used by other applications. But their full-time job is not to work on this kind of stuff. We have instead a group of volunteers named Ruby Core that dedicate their time to making this happen. So at least one member is required to review each PR to ensure we're not breaking changes unexpectedly, that change logs are updated. That's a thing that, you know, if you're like, hey, what changed between these two versions? And if you forget to include something, they're like, oh, then they ask a question, and then you're like, oh yeah, that changed in this version. And you're like, well, it wasn't in the change log. You could have saved them 25 minutes because they were digging through a bunch of code, trying to figure out what changed, and it could have just been there. And obviously just general code review on top of that. So we release versions on a train schedule. So this is popular with a lot of mobile applications, but it means we just schedule releases. Unless like an immediate patch version needs to go out, we release roughly on the 1st of every month. It's like April 6th, 7th right now. I don't remember the date, but like I haven't done the release yet, so I'll get around to it this week. So we're not perfectly on time, but in general, engineers expect one release a month. This regularity gives people confidence that releases just aren't pushed out willy-nilly, right? They're not like, oh, well, you released that today, is it gonna work for me? And allows teams to budget time in their engineering schedule to make sure they're up to date. It's a common problem. You'll see like, oh, push out this library, and then nobody updates. And then you're like, well, then they complain like, hey, this is a bug. I'm like, I know, I fixed it 6 weeks ago, and you could update, or even 2 years ago, and you could update. So when we release, we strictly stick to Semver. Feature additions like a new gem integration are opt-in by default. So that's why on the previous slide you saw some of those are opt-in by default, because we added them after the last major release. They have to be enabled by, they're opt-in. So in general, the release of SQ Common each month is a minor release. And other gems depend on the changes. So even though, let's say, like SQ Metrics just went a major version bump, that wasn't a major version bump for SQ Common because primarily that API is only used by SQ Common. We kind of make that all easy for you. So we're not releasing a new major version every month. which means people see and you see a minor version bump, and you're pretty confident that like you're like, hey, if I just bundle update, it'll be fine. So some of these version constraints we express in the gem file, some of them we don't. The upside of having a gem file is bundler works a little bit better. The downside is it means if you want to ease people onto this, it doesn't work. So SQ metrics is significantly, and SQ connector are significantly older than SQ common by more than a few years. The problem is, let's say they're on a really old version. An application I recently helped upgrade was on 2.0, which was released in 2016. The problem is if you have strict version requirements in your gem file, you can't bundle update. It just won't work. So instead, we run those at runtime, and only if you've enabled that section. So you're like, hey, I want auth via SQ common. We'll go, OK, then make sure you're on at least this version. And if not, we tell you to update, and you can't really run any commands, so all your specs fail. It's a pretty obvious thing. It's not as immediate as your bundle update fails, but it eases that migration. And that means you're not going to have one giant PR, especially if you're migrating onto SQ common. You add SQ common with everything disabled, including the things that are enabled by default. And then you can slowly integrate one by one until you're done. So with our next major release, we're going to be moving everything back into the gem spec because we've gotten almost every single application onto SQ common. So basically, it's going to be 6.0. It's going to be flipping some things on by default, forcing some other things on, and just changing the versions back into the gem spec, and then you're done. That's going to be the whole release. You'd be like, oh, well, you need to upgrade to, you want to get on and just use the latest 5.0 release, 5.x release, then you can easily update to 6.x. You're done. This doesn't work anymore. Everything's broken. Somebody else updates. Everything kind of goes bad. So in addition to all the specs we have for those, we also have a Rails 4 and a Rails 5 test application, which are the two supported versions of Rails at Square, that run the whole thing. And we run like 12 different configuration files. So we can say like, oh, you enabled this thing, but disabled this thing. Make sure everything still works. You enable this thing, but disable this thing. Or you're just running plain vanilla. Does everything still work? And then for all of that, we multiply that times the 3 different versions of Ruby, or the different versions of Ruby we support at that time. That's currently 3. We've got 2.4, 2.5, and 2.6. Used to be just 2.4 and 2.6, because 2.5 has been a little bit bumpy. But in general, when we know the CI passes, we're pretty confident that everything should be fine. And another note is that for pull requests that we know require a major version bump, maybe we're removing a file from a gem or changing a public API or something like that, really anything that's a major version bump, we wait to merge those PRs. So anything that's a minor or patch change gets immediately merged once it's green and everyone's happy with it. But when it comes to the release train, first off, we release all the versions that are only either minor or patch, except for SQ common. Then we merge the major change PRs, and then we release those gems, and then we update SQ common to say, hey, these are the versions you're allowed to work with. So that means you can say, let's say somebody puts in a bug fix, and it's like, hey, I need this bug fix, but they don't necessarily want to update SQ common that day. They can just get that exact one bug fix. Instead of, oh, well, you don't get that version unless you're allowed to work with, that version that just had a major PR, and maybe that's too difficult for you. So some development practices and tips from what we've learned. We just had our 1-year anniversary of Ruby Core a few months ago, so about a year and a half. And we've kind of gotten the stride and seen what's worked and what hasn't. First off, just don't try to build the whole world if you only need one small piece. Feature removal is a major version bump. Feature addition is a minor version bump. Way easier. Release the code with just what people need and what you think people need at that time, and wait for people to request more. They will, write it then, but it also gives you insight, especially if you're rewriting something, of what they think the public API should be and what it needs to have happen. Like, oh, you need to you want to validate the session. You don't want one jumbo method. You want to be able to make it something that's elegant and people want to work with. So as I kind of alluded to, next up, build public APIs that are elegant. Like if you're writing a client for API of another application, don't just copy the fields that go on the request, make those the arguments, and like, ta-da, be done. Having 10 slightly different methods that take different options, but are explicit in the exact options they want, are significantly easier to document and read than one that just has 40 different options, because those are all the fields that could be on the request. And it's much easier for a developer if you just look at the code, you're like, oh, this is that one parameter I need. I don't only need these two things together. And with the advent of keyword arguments, these APIs are even most of the time self-documenting, and everything's just a little bit easier. Another thing we recommend is pinning for open source gems, pinning to exact versions, or if you're not comfortable with that, just allow variations in the patch version. Unfortunately, it only takes one library to change something and break everyone's application at the same time, and then you have 30 different people going like, hey, did anyone else get this error? It happens a lot. Happened a week ago. Semver is very much as much of an art as it is a science. Like, it takes a while to get used to, like, oh, what do you think people did with your library? And maybe this might be a breaking change for them. So often we find that it's easier to pin to exact versions. And then when somebody's like, hey, I need this feature, we bump it, goes out in the next release, really easy. We actually recently had a case where a patch version included some feature additions, ended up being a breaking change for us, and it was only noticed when deployed. Didn't break in CI, didn't break in development, only in production. Not good. Everyone's like, hey, this is going wrong. And even worse, it was in a library that was doing some stuff in the background. So you didn't notice until you looked at your logs, and it was there. And then even worse, it wasn't in the changelog. So I looked at it, I was like, hey, everything doesn't look like that version bump should be an issue. And then I looked at the diff, and I was like, well, there it is. So version dependencies for internal gems. We don't really ever pin to exact versions. Instead, we allow any version within a major release by default. The idea being that if we're internally sticking to Semver, that shouldn't be a problem. But let's say we do, like for SQ connector, I think the current release supports 3 different major versions because there were some feature removals, but in itself wasn't a major release for SQ Common, and all 3 of them worked. We always make sure there's a max version. So let's say we're releasing version 10. So version 10 is the max version of SQ connector. The current gem spec requires less than 11. The reason we do this is, let's say, a little down the line, we release 11, and it actually has a breaking change that doesn't work with your version of SQ Common or any other libraries. You just run a bundle update. It's going to find 11 and be like, cool, everything's good, if you only update that one gem. The problem is that if that doesn't work, then you're going to have some issue. So we always make sure that there's a max version. So if you run a bundle update, everything is happy. Nobody gets a version that's like, oh, well, we knew that doesn't work with that version, so just update something or don't update that. Becomes trickier. And in general, less people ask questions, more self-service, everyone's happier. And last, I've mentioned this a bunch, but stability is just paramount. Before we started following a lot of points on this slide in the previous one, there were many times where we would release a patch version and it would break everything. You have like 20 different people going like, I updated and then now I'm hitting all these weird errors. And as a result, teams started to fall further and further behind. Because it was too difficult to upgrade, maybe they're like, oh, I'll do this a little bit later. And then even when they'd think about proactively upgrading, even if we'd gotten a little bit better, they're like, no, your track record says it's broken every other day. We're just not going to. And then a few months later and a few years later go by, and then guess what? Nobody knows that code anymore. People are going to ask you questions like, hey, what is that API? And you're like, what version are you on? 2.0. And you're like, we're on 5.0. 2.0 is a few years ago. Let me go dig through it myself. You know, I can answer off the top of my head most of the common questions about our public APIs and stuff, but that's recent stuff, not 2 years ago. So we recently helped a bunch of applications upgrade to SQ Common, a handful of applications that my team owns, your team owns, Bob and Peter's team own, and some of them were just on libraries that were 2 or 3 years old. And so that's why I kind of mentioned in the previous slide we didn't have those strict version dependencies in the gem spec, because we could add just a little bit of piece here and there. And it meant that deploying wasn't super scary. They were like, most everything looks like it works. We deploy to staging, everything it works. those small pieces made everyone a little bit more confident that like we're not going to take down our support center in one case, which is not very good because then people can't get any help and then it's really bad. So it just just creates more work when it's not stable for everyone because the community can't answer those questions because people are 3 years out. So now that we've been able to produce that stable release pipeline for over a year and a half, we actually do see teams keep up to date. They might be 2 or 3 versions old, but they're like, oh, hey, we announced this feature in 5.14. It's like, what version are you on? 5.12. Cool, bundle update. And that's all you need to do, right? You're like, there's no like questions, maybe this will work, maybe it won't. You're just a bundle update and away from like staying up to date. So thank you very much. Any questions?